I'm Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about the computer network subject, in which the topic is a congestion controls. Here the outcome of the congestion the controls are, so the efficient traffic management can be done by controlling the congestions. The traffic management will be efficiently can be managed. That means now for that now token bucket algorithm and leaky bucket algorithms. We can use the token and leaky bucket algorithms. So by using that one, the traffic in the real time of the scenario, the smoothly so efficiently the traffic can be managed, which ensures very smooth the data flow while allowing the burst of the traffic, now optimizing the network the performance. And these with help of these congestion the control now improving the more the flexibility to the network, that is dynamically adjusting to varying the network loads, preventing the other congestions. This the congestion control now, which is preventing the other congestions while maximizing the bandwidth the utilizations. Better quality of the service the support now, which is by regulating the transmission rates, which is, so it is enhance the quality of the services for the real-time applications like video streaming and voice over the internet. The quality of the better quality of service can be provided. The best example is Netflix, Amazon, YouTube. These are all the best example now. So this the congestion control, while controlling this the congestion now, better the quality of the services can be provided. Here the congestion. The congestion means now what is the congestion? Congestion in a computer network generally happen loading. The more too much data is being sent at the same time. Too much data now. If load more data, if the sender is loading the more data on the network now, generally these are the congestions will be arise. So which is causing the network now slow down. Network will be slow down. If it is a congestion is occurred here, whatever the network, that network it will be the slow down now due to the heavy traffic. Just like the traffic the congestions on a busy roads. Busy roads now it is a congestion. Network the congestions which lead to the delays. Sometimes now data is the losses. Data will be the losses due to these other congestion. The effects of the congestions in a computer network. Generally here now, which is the effects are generally improved with this other congestion, in a computer networking here, any networking. Generally which is improving the network the stability. That the congestion controls now, which is prevents network overload, which is ensuring the very stable or uninterrupted the data flow. So this is the network, the stability can be improved. These are the congestions now, which affects reducing the latency and the packet loss. So these packet loss means now what will happen means now transmission delay occurs, which minimizing the transmission delay. Delay will be the minimized and data loss, making the network very faster and more reliable. So this is the reducing latency and the packet losses. Enhance the throughput. Enhance the throughput means now here is now which is optimizing the resource usages. Whatever the resources we are using here, now it will be the optimizes the resource usage. The congestion control will be allows higher data transfer rates and better the performance can be achieved with enhancing the throughput. Throughput means now per second how many data packets are transmitting is the throughput. That will be number of the data transmissions per second, that will be increased. That is enhancing the throughput. The optimizing the resource and utilizations. Number of resources or number of data packets can be transmitted per seconds will be the increases. And here better user experience. Better user experience means now which is smooth and efficient data flow. smoothened the efficient data flow now, which is enhance the very reliability. The accurate data can be transmitted from the sender mission to the other receiver mission now, which is responsible for the online applications. Now there is a better user experience, mitigating the network congestion, the collapse. If is there any networks are the collapse with these congestions now, so that the collapse network the collapse can be mitigated, reducing that the collapses. It prevents the several the traffic spikes from the overloading of the networks, and which ensures now avoiding this the collapse. Network the collapse, the congestion the collapse now continuously, which is supporting for continuous data transmissions. So that is the mitigations of the network the congestion collapse. And here the congestion control algorithm, generally here for controlling this the congestion, we are using the two types of this congestion control algorithm. One is the leaky bucket and token the bucket algorithm. Now these two algorithms in a computer network now. So controlling the congestions over the network, computer network. Congestion control is a mechanism that controls the entry of the data packets into the network. Mainly here, whatever the data packets are entering, so that will be the control. So sharing the network the infrastructure, avoiding the congestion collapse. So this is a congestion control. Congestion avoidance algorithm. So congestion avoidance algorithm, that is a CAA. So generally now, so it is implemented at the TCP layer, transmission controller, that is at a transport level. So in a voice reference model now, while communicating these the devices now, it is implemented, the congestion, the avoidance algorithm can be implemented at the transport level. Transport level as a mechanism, these are the mechanism what it is doing now here, which is avoiding the congestion. So collapsed networks. Now, whatever the other congestions are by occurring these congestions and whatever networks are collapsed. With help of with the due to the region of this other congestion now, that network the collapse can be avoided, mitigating the network the collapse. So with the help of this the conjective the avoidance algorithm, the congestion avoidance algorithm. So generally here in a computer networks now, there are two congestion algorithms can be used. So with the help of these two congestion algorithms now, so traffic can be transmitted very smoothly from source mission to the other destination mission, any over this other communication media. So that algorithms are the leaky bucket algorithm. First algorithm is a leaky bucket algorithm. Next token bucket algorithm. With the help of this leaky bucket and token bucket algorithm now, the congestions can be controlled. Leaky bucket algorithm. Leaky bucket algorithm now, what it is doing now, here which is transmitting the rate-based the congestion control. So rate-based congestion control mechanism. So that means now which is regulating the data flow. Regulating the data flow and preventing the other congestion. That means now, so it is regulating the data flow and preventing the congestion. So that means now, which is ensuring that the data packets are here. This is the inflow may be burst. More number of the data packets may be arrived in a inflow. But the outflow here, the constant rate. The outflow will be very constant rate now. The data rate based. That's why this algorithm now we are saying it as the leaky bucket algorithm is a rate based algorithm. Rate based algorithm means now outflow will be the very constant rate now, which is sending the data packets to the other destination. But from the sender mission now, from the sender host mission, the inflow may be the, so it is not a regular. It is irregularly the data flow may be. That means in 10 seconds, 100 data packets are coming. Remaining 3 seconds now, 50 data packets are coming. So the data rates are incoming is irregular, but outgoing is a constant data rate now, which is transmitting to the other destination. So for 2 seconds, 3 packets only it will be transmitted. Next to 2 seconds, 3 packets will be transmitted. The data rate should be the fixed data rate. The transmissions can be done with help of the leaky bucket algorithm. Here, how it is working means now, working principle now, these are leaky buckets with a small hole at the bottom. And the bucket now, leaky bucket, just like a water bucket now, here is the data packets is added to the bucket at an irregular rate. That means these incoming data packets are irregular. irregular rate. And these are the buckets leaks water at a constant rate. Constant rate means now the data packets are sending fixed the flow. 2 seconds, 3 data packets are sent. Next 2 seconds, remaining 3 data packets constantly with a fixed data rate now, which is transferring the data packets now, which is ensuring a steady output flow. The output flow will be the very steady state now. If the bucket is overflows, that means incoming rate is greater than the draining rate now. With the excess water is discarded. If it is water is the excess water, so with this the leaky bucket of the principle now that will be discarded. Steps generally here, the packets arrive at an irregular rate and are stored in a buffer. That is a bucket. Buffer is nothing but a bucket. Whatever the packets are arriving, so that will be stored in the bucket. These leaky bucket algorithm now, the packets can be transferred to the destination at a fixed rate. Destination mission. The packets can be received in an irregular way, in an irregular pattern from the center mission now, and to the destination mission, this leaky bucket algorithm, with the help of this algorithm here, that can be transferred to the other destination with a fixed rate, which ensuring very smooth the traffic flow. Traffic flow will be very smooth and very comfortable. If it is so if the buffer is full now, incoming packets are dropped at preventing the other congestions. The example of the scenario without leaky bucket now, a sender transmitting 100 packets per second for the first 3 seconds and 10 packets per second for the next 5 seconds. Sudden traffic burst overloaded the network, causes the congestions. This is without leaky bucket. If it is the bucket is leak, the bucket is the leaky bucket algorithm now. Leaky bucket ensures that 50 packets per second exit the buffer. Per second now, the 50 packets, whatever these irregular the packets are transferring, only with the constant round which is exiting the with a fixed rate, the packets can be constantly now, which will be sent out here, preventing the congestions and maintaining the steady flow, maintaining the steady flow. Here is now the advantages. The advantages of this the congestion control now, which is preventing the network congestions, controls the burst traffic, smooth data and transmissions can be done. The bandwidth of the allocation, with ensures no single sender and a monopolization network of the resources. Here is the implementation now uses the queue. FIFO, by using this first in first out of the mechanism now, whatever packets are arriving first into the buffer here, that packets can be sent out. With help of this FIFO mechanism now, it is working. Implemented these leaky bucket the algorithms. And the disadvantages, bucket may be dropped. Packets may be dropped. If the packets may be dropped here in a bucket, if the buffer is full. When it is packets may be dropped with the buffer, excess buckets are lost. Not adaptive. The rate of the flow is fixed. Here is which may not be the ideal for the variable network of the conditions. This is not adaptive, is a disadvantages of the this leaky bucket. Token bucket algorithm. Token bucket algorithm, it is a rate-based congestion control mechanism. This one. Generally, so it is a regular data flow while allowing the burst traffic. The regular data flow now, which is allowing the burst traffic. Now the data is flowing. If it is the full, the data will be overloaded. Once the tokens are added to the bucket at a fixed time rate. At a fixed time rate now, number of packets can be added. So from that now, the host mission now, the data packets can be added in a buffer. The bucket holds all the incoming packets. Once now, if it is the full here, waiting, which make the waiting state to the host of the computer. Host computer should be in a waiting state. Once the availability is there, if the availability in a token bucket of the algorithm here, in a buffer, if the availability is there, then only which is allowing the other packets. If there is no availability in a buffer here, so which is making in a waiting state, whatever the packets are incoming here, all the packets can be made in the waiting state here. This is the token bucket algorithm. And here if it is vacating, that now whenever the network, whenever the destination mission, whenever the destination mission now, which is asking the data packets can be transferred to the destination with the flexible rate. flexible rate. Here it is a more flexible than the leaky bucket algorithm. So it is allow the data transmission in a burst when tokens are available. When tokens are available. That's why it's a more flexible comparing with the leaky bucket algorithm. So it is a rate-based congestion control algorithm. Fixed data rate. The data packets can be transferred with the fixed data rate. Token bucket algorithm is imagining the bucket now that holds the tokens inside a bucket. Tokens are generated at a fixed rate and storing in the other bucket. Here is due to sending the data packets, a sender must take the token from the other buckets. If there is no tokens are available, the packet must be wait. Here is if the tokens, if there is no, the packets not available, any tokens are not available in the buffer now, the packets must be wait until a new tokens are generated. The leaky bucket, unlike this leaky bucket token bucket algorithm now, which is allowing the burst transmissions, if even the tokens are accumulated, how are they accumulated? So this is the working principle of the token bucket algorithm. Generally, the steps are tokens are generated at a constant rate from the host of the mission, central mission, and stored in a bucket. At a constant rate now, per second, 20 tokens will be generated. Next second, 20 tokens. Next second, 20 tokens. With a constant rate now, so that will be generated in and stored in a bucket. Once the bucket is full, the token generation will be the stop. And from this the buffer here, from this the buffer, the tokens will be one by one tokens can be retrieved and that will be transferred to the other destination mission. Generally, this is the working principle of the token bucket algorithm. When a packet is arrived, it removes a token from the other bucket before being the transmitted. If there are no tokens, the packet must be wait or dropped. If there are enough tokens, or multiple packets can be sent at once. If the tokens are available, multiple packets can be sent at once. Here is the advantages are, which is allows the burst traffic. That means unlike leaky bucket algorithm, which permits the sending burst if the tokens are available, which prevents the packet loss. That means now how it is preventing the packet loss means now accumulating the tokens, which is allow the immediate transmission whenever it is needed. More adaptive comparing with the leaky bucket algorithm. The token bucket algorithm is a very more adaptive, adjustable, better to varying the network loads. That means now if it is full, it is waiting. Make the devices, make the client devices now, make the host devices in a waiting state after vacating that the buffer. The disadvantage is more complicated now for implementing this token buffer. Why? Because now requires the tokens, token generations, and synchronizations. Here is may delay packets. If no tokens are available now, packet must be waits. So the token generation and the synchronization is a very complex task. This is the disadvantages of the token bucket. Main differences between the token bucket and leaky bucket are so in terms of this traffics now, token bucket algorithm now which allow the burst traffic. Leaky bucket algorithm, constant output rate. Leaky bucket algorithm. Packet packet in terms of packet dropping here is a very rare. Packets are not, only if the bucket is overflow, then only the packets are dropped. So up to that now, if it is a overloading means now it is making the clients the devices in a waiting states. That's why the packet dropping is very rare. Dropping the packets if the buffer is full. Whenever the buffer is full, the packets will be the drop. The flexibility means now in terms of this flexibility, the adaptive now which is allow the burst errors now which will be allowed. In terms of the layer bucket of the algorithm now fixed, does not allow the burst. Here the textbook for this one is a data communication and networking, A4 region and computer networks, S the Tenenbaum. So this is the textbook for this congestion controls, and so it's a very effective. The congestion controls are very effective for data for the transmissions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.